Morning. In this tutorial we are going to learn about design compiler. It is a synthesis tool of Synopsys, and by using it we synthesize our RTL or architecture level design to gate level netlist. First you have to source the license file. For that you have to go to this directory. Here after sourcing license file you have to go to lab, and for the design compiler you have to go to DC lab. That you have to go to RTL. Here you can place or write your design file in any language, Verilog, HTL or EDIF. As an example, we will be running uh, the design file named counter, and here it is. This is the counter file which we will be synthesizing with the help of design compiler. Now we are going to invoke the tool, and for that the command is this. The tool is invoked and you can see the graphical user interface of the design compiler. That you have to go to file, read, you have to read the design file, and this is the design file we are going to read, and the design file has been read. And under logical hierarchy tab you can see this is the GTEC representation. Clicking on it and go to schematic view, you are able to observe the schematic of the counter file based upon the mapping. This is the schematic of the counter file. Now the next task is to synthesize. Is first command is check what is the current design. It is counter 4-bit. Then we have to link it to the library. It is okay. Then we have to enter some constraints for synthesis. Create clock of period, let's say 5, and then name. The name of the clock, here you can say it's TLK. You have to provide that name only. Then is TLK. Okay. Then you have to set the input delay. Let's take 2. Clock is TLK. Move from galaxy all. Next, setting output delay. These values which we are taking for random depends upon complete system design for of who this counter can be a part. And they must be constrained on the input and output delays, which we have to provide here. But here, for particular for particular counter, it is taking random values. Otherwise, we are constrained at these input and output delay values. Then setting clock uncertainty. Let's take 0.1 and all. Then setting the wire load model from which the resistance and capacitance values will be taken of the nets. The name is this connection. Then setting clock latency of 0.5. Then setting a capacitive load of value 0.5. Just wait. Okay, so we are setting capacitive load on all outputs. Okay. Now finally we have to compile the design that will synthesize it to gate level netlist. You can see the results of the compilation here, or you can see it in the reports. So let's see the gate level netlist, gate level representation of the design. Netlist is right in a file and observe later. This is a gate level representation of the 4-bit counter. As you can see, by zooming in, okay. Now after that we can see the reports. For example, report hierarchy, and here it shows the hierarchy. Then report references. After the 11 references used in this design, that means the references to libraries. You can see the resources, report area, report power. You can see the power command, max export. And if you find any error here, you can go to this and see what is mentioned here, and according to that you can modify your command and manage things. What time flag has been met by 0.02, means the design is still good. report quality of results. Finally, we have to write the netlist file, netlist to a file. So this is how we write -o, then name of netlist file. This is netlist August 1930 written. Now the work of tool is over. After optimizing, you can again come to this tool and do the synthesis. Thank you.